Hello class, so this is the first probability review for the finals review. I'm going to do this first part in two parts. So in this video I'm going to do numbers 1, 3, and 4 from your final exam review. Alright, so let's get it started with the first problem. It says the following table shows the number of vehicles owned per U.S. household and the corresponding proportions. The proportion is the probability that that number is going to occur, essentially. So one thing you may notice right away is that there's a missing piece. Well, probability always adds up to 1, okay? Or is always out of 1. So I need all of these to add up to the number 1. So to find the missing piece, let's add the other numbers. So 0.04, look at my calculator. I'm going to add these up. 0.25, 0.18, 0.06, 0.02. Okay, I messed up somewhere. I know where. I needed a decimal there. Sorry about that. So that is 0.55. I need these to add to 1. So all of the other numbers add to 0.55. Which means the missing piece is 0.45. If they haven't corrected it yet, there was an error in the answer key when I checked it. So that should be 0.45 because I need those numbers to add up to 1. And now they do. So this says, what is the probability that a randomly selected household has 2 vehicles? Well, now I know that the probability that that's going to happen is 0.45. Again, the answer key had that wrong. It said 0.55. That was just a calculation error. Their work is actually correct. So if they have not yet corrected the answer key, just know that the answer should be this, 0.45. So now it says, what is the probability that a randomly selected household has at least 1 vehicle? And there is a really important part of this, and it's the word at least. At least means it could have more. So it could have 1 or 2 or 3 or 4 or 5. So basically, I want to add up the probability of each of these. So I want to add up, I'm putting a box around these probabilities. I want to add up these probabilities. 0.25, look at my calc, plus 0.45, plus 0.18, 0.06, 0.02, and the answer is 0.96. That's how I would do the problem. In the answer key, they do the number 1 minus the only one that it's not for at least 1, which is another way to get the correct answer. But that's how my brain works, is to add up the numbers. All right, last one. What is the probability that a randomly selected house has at most? And that's really important, 3 vehicles. So it could be 3 or less than that. 3 or less. So if it's 3 or less for at most, then I'm going to add up these ones. So in my calculator, 0.04 plus 0.25 plus 0.45 plus 0.18. And that answer is 0.92. And again, they show their work a little bit differently than I, but this is how my brain works, so that's how I would do it. We're going to move on. I want you guys to try the next problem, which is very similar to number 1, so you're going to try number 2 on your own, and we're going to move on in this video to number 3. 72% of U.S. children ages 6 to 12 play at least one organized sport. You randomly select 8 U.S. children and ask them if they play at least one organized sport. Use the binomial probability formula, showing the formula and numbers plugged in, to find the probability of each of the following. All right, so it says you randomly select 8 children. That's the N value. That's the number of trials, okay? 72% is a yes answer. So that is going to be the P, which is the success. I'm going to change that to a decimal. All right, well, obviously the two probabilities, yes or no, so success and fail, have to add up to the number 1. So 1 minus 0.72 is 0.28. So if it's a 72% chance that someone's going to say yes, that would mean that there is a 28% that they're going to say no. All right. And that's pretty much what we need to know. So if I want exactly 6 of them to say yes, then it's going to be this. This is how I show my work. 8 choose 6, which on the key they write 8C6, which is how we're going to type it into our calculator. We're choosing 6. Now the success is 0.72. And we want 6 of those. The fail, or the no's, are 0.28, and we want 2 of those. So the way I always taught this was that the 6 matches that first number. So the part of the choosing part, so 8 choose 6, that choose part is going to be the first degree, and then these 2 degrees, 6 and 2, those 2 have to add to the top number. That's how I always memorized the binomial theorem. Okay. All right, so now this is just something you're going to type right into your calculator. So math, probability, NCR. So it's 8 choose 6. Oops. Really should put parentheses around this. Times 0.72 to the 6th times 0.28 to the 2nd. That's where we get our answer, 0.3058. And that is the answer. Okay, at least 7 of them respond yes. At least 7 of them respond yes. Okay, so if at least 7, that means 7 or 8 respond yes. So we have to do the binomial theorem twice with each of these numbers. So 8 choose 7, 0.72. We want 7 of those to say yes, which means only 1 says no. And then since it's or, we're going to add that to 8 choose 8. We want all of them to say yes, which means none of them say no. And just plug and chug. Uh-oh, forgot parentheses. Let's do that. 0.72 to the 7th times parentheses 0.28 to the 1st. That's just the first part. 0.2247 plus, I'm actually just going to make my life a little easier here and copy paste and just change some numbers. So 8 choose 8. There it is. Plus 0.0722. So I'm going to add these two numbers together for my final answer. 0.2247 plus 0.0722. Final answer, 2969. Alrighty. You know what? I might as well do the last one. It says exactly 7 of them say no. There's more than one way to do this. I actually disagree with the answer key. So this is how I would do this one. There's, I guess, 2 ways to do this. If 7 of them say no, that means only 1 of them says yes. Okay, so this is what I did. Now, instead of doing 8, choose 7, I did 8, choose 1 because I really only want 1 success. And I actually think if you do it a different way, I'll show you a second way to do it that you'll get the right answer. But his answer key is wrong. All right, so this is how I would do it. So let's try this. And let's just make sure we get the same thing either way. All right. I'm not going to steer you guys in the wrong direction, I promise. Okay, so, oops, I deleted that. So probability NCR, we're going to do 8, choose 1. And we want 1 success. We want 1 yes. And that means we want 7 no's. And that's exactly what it's asking for. It's saying 7 no's. All right. 0.000, let's say 0008. That should be the answer, not what he has. Now, I think a second way that we can do this is this. Let's see, 8. Okay, same answer. So another way that you could do this, I'm going to show you what I did there, is 8, choose 7. But we want 7 no's. So that's why I switched this around. So this is the probability that it's a no. And then that means that we would just have 1 yes. But it doesn't matter if you do it this way or this way, you should get that same answer. So this is the correct answer, 0.0008. Alrighty. Last one on this video I'm going to do is this Venn diagram. Now, this is a tough problem. We didn't really do Venn diagrams when we learned this. So there is one on the final. I'm going to have you guys try it. We'll see what happens, okay? So it says a survey asked residents in a city if they favored or opposed the installation of a red light camera. 48% of the residents surveyed supported the installation. 65% of the residents were male. 27% were males and support the installation, okay? So there's a lot to kind of unpack here, and to do that and make a Venn diagram, we're going to use this chart. So here's what we do know. We know that 48% support the red light camera. Okay, 48% support. All right. Now, 65% of the residents surveyed were male. All right. So the total amount of males were 65%. Now, 20% were males that supported. So that was this piece right here. So males that actually support the camera are 0.27. All right. But the total amount of males in general, or people who identify as male, is 0.65. Okay. So we have to fill in the blanks from here. All right. Obviously, you know, this is an old problem. So it's male and female. You know, we could say that there could be now a non-binary column. So let's just let's just understand that this is kind of an outdated problem, and we're just going to go with the male and female pronouns, okay? So assuming that all the residents surveyed identified as either male or female, then if 65% are male, that would make 35% female, which gives me a grand total of 100%. All right, buddy. All right. Now, I know that there needs to be 48% of people that support the red light camera, which means if 27% were male, 48 minus 27 is 21. That means 21% would be female, okay? And then let's fill in the blanks here. Side by side, 65 minus 27 means that if 27% of males support the red light camera, that means that 38% of the male residents oppose. And then going side by side here, 35 minus 0.21, 0.35, sorry, minus 0.21 is 0.14. Okay, so the way that I'm filling out this chart is that these two side by side need to add up to 0.65. Side by side, these need to add up to 0.35. And then up and down, they need to add up to the total numbers, okay? So that's how we're filling out this chart. So that means that to find this missing link, what do? I'm going to add 0.38 plus 0.14, and that's 0.52. All right, so I've filled in all the missing pieces. How can I represent this on my Venn diagram? Come here, buddy. It's okay. Okay. So it looks like the Venn diagram is talking about people who support and then people who are male that support. So people who are male and they support, that's 27%. That's the overlap. Okay. The males that do not support are going to be out here. Oh my God. I don't know if you guys heard that, but Louis has some gas, so it is what it is. All right. And then people who support that are not male would be females that support. So that's 0.21. All right, so I think the Venn diagram's a little bit confusing. Again, I just think about the overlap. So the overlap are going to be males who support, and we decided that that was 27% based on our chart, males who support. If it's a male, but it's not overlapping with support, then that's males who do not support, so they oppose. All right, and then the grand total for males is going to be the 0.65. All right, and then if they support, but they're not male, that would make them females who support. So that's where that 21% comes in. And people who support add up to 0.48. So this checks out nicely. And then once you have that Venn diagram created, it's okay, buddy. It's okay. We're so close. Then you can answer these questions. So it says, use the two-way table or the Venn diagram to find the probability of a randomly selected resident is male and opposes the red light camera. So a male who opposes, that's 0.38. Honestly, guys, I would use the chart more than the Venn diagram. The chart makes more sense in my brain. That's just a personal preference. Okay, supports the red light and is female. Supports and is female. Supports female, 21%. Female and opposes, 14%. Supports the red light or is male. Okay, So supports the red light in general is 0.48. Or is male. Now, this one's kind of hard because 65% are male. However, we're double counting. We double counted this. So we have to subtract that out. And then that adds up to 0.86. Okay. 0.48 plus 0.65. But we have to subtract out what we double counted. So that adds up to 0.86. All right. So that last one was hard. I hope that my explanation made sense. Honestly, I like this chart much better than the Venn diagram. I don't even use the Venn diagram to answer the questions. The chart is difficult to figure out, but once you understand what you're doing, I think it makes a lot more sense. So I want you guys to try this based on what we just talked about. Give it a go and check your answer. Thank you.